Hello everyone, and welcome to our dissemination event on successful innovation in manufacturing using the Internet of Things. My name is Alexandra Brintrup. I'm a lecturer in digital manufacturing at the University of Cambridge, and I'll be chairing this session. Before we start, some housekeeping rules. Please stay muted unless invited to speak so we don't have any background noise. By clicking on participants, you can view who is here, and on that front, if you haven't already done so, do edit your name and affiliation so people can find you. During the presentations, we won't be taking any questions due to time constraints, but please feel free to add any questions in the chat box and speakers will get back to you. And then we also have a slot at the end for discussion. We'll be recording this event and share a link with you afterwards. And if you have any technical questions, please contact Elizabeth Hancock, whom you can find on the participants list. Okay, so welcome to IoT in Manufacturing, which forms the dissemination event of the manufacturing stream of Pitchin. It's wonderful to see so much interest, and we hope to have some very good discussions today on how IoT innovation can be used and adopted in manufacturing. So today's agenda is the following. I'll first give a very brief overview of the Pitchin project, and then we will present a selection of mini projects and teams that have come out of Pitchin so far. And then we'll do a Q&A. We would love to get your views on especially where we should go next. And we hope to close by 3:30. So Pitchin stands for Promoting Internet of Things collaborations between higher education institutions and industry. And it's a collaboration between 4 universities, namely Cambridge, Oxford, Newcastle, and Sheffield, and the consortium is led by the Sheffield University. So we started in 2018. To identify barriers to adoption of IoT innovation in the UK and to find out ways to overcome those barriers. So Pitchin is funded by Research England's Connected Capabilities Fund, which supports knowledge transfer and aims to connect expertise between industry and universities and also between universities. IoT is very much part of the UK's productivity agenda, and it underpins the UK's industrial strategy, yet adoption rates were slower than expected. So our project came right about when the green paper on Made Smarter was published. So stars were very much aligned for us to conduct a large-scale project to demonstrate the benefits of IoT to industry with a view of creating a sustainable ecosystem of connected IoT stakeholders. We organized Pitchin across 5 horizontals covering health, energy, smart cities, and manufacturing, as well as cross-cutting theme of social sciences, which we felt was an overlooked area in IoT at the time. So on the horizontals, we look at technology, business models, strategy, and also engagement, which has been a big part of our work to ensure we can successfully put together a group of IoT stakeholders for the future. So as IoT is a vital enabler of Industry 4.0, Pitchin manufacturing is one of those verticals, and it specifically explores manufacturing. And by manufacturing, we not only are considering the factory, but also supply chains, logistics that support the factory, and assets, and also innovation management. We have had to date about 18 mini projects that lasted anywhere between 3 months to 2 years. 12 of these were in Cambridge and 6 were in Oxford and Sheffield. And the vast majority of these projects were collaborative, and they included multiple universities and industrial partners. We followed a semi-emergent approach in that we had an inclination of what topics might have been of interest, but we let the researchers and industry decide what was their priority. And in the end, our kind of post hoc analysis shows 4 main clusters emerging. These are achieving low cost and legacy integration, supply chain integration, novel applications, and new business models underpinned by skills. This is a quick overview of the geography of our industrial partners within the team. We had very much a regional engagement focus, which centered around the North Central and South and East Anglia regions. We had a diverse range of industries from SMEs to tech startups and as well as large multinationals. And it's important to point out that when we explore IoT in manufacturing, we are not anymore only talking about manufacturing engineering as an academic discipline, because IoT cuts across by its very nature to innovation management, automation and control, as well as AI and data analytics and operations and supply chain management. So we engaged academics from all these different disciplines. Now, a very quick overview of example projects you might see today. In the first theme that emerged, which was low cost, our approach has been demonstrator-led. And we looked at developing solutions on the shop floor with a cap on cost, often repurposing existing legacy systems or using non-industrial generic technologies such as your Amazon Alexa or Raspberry Pi. On the supply chain side, we focused mainly on data integration and interesting applications that were enabled by doing so, such as autonomous supply chains and digital twins. And speaking of novel applications, we had a fair few. Anything from quality control problems on the shop floor to speech recognition, and even during the pandemic, applications of manufacturing principles with IoT to hospital environments. There was a fair amount of excitement around new business models, which we looked at as well. One of these, which my colleague Dr. Frank Tietze will talk about, was the use of blockchain technology coupled with IoT for automating IP licensing. And another one was to try and understand when product customization that is enabled by IoT is actually worth it. So we'll see a variety of those today. And when we examine which barriers we are addressing mostly, it's a diverse and rich set. Primarily, I'd say collaboration and the business case for IoT, because many of these projects wouldn't have been possible without pitching, and the collaborations have been long-lasting. So we had several proposals and patents in the pipeline, as well as a startup company. So some of our key conclusions as a consortium are that our semi-emergent approach to mini projects was key, because it gave academics and industrials freedom and time and space to really think about out-of-the-box projects with small pots of funding. And demos and hackathons were a really great way to engage students as well as industry, because it helped form connections by attacking problems together. And the trade shows was an interesting one. As an academic, I've never been to one, but now I really make a point of attending at least once a year to learn from innovative companies and also ground our research in practice. So, and finally, I'd say engaging early career researchers was very helpful, as they took ownership of projects and energetically attacked the problem space. So with that really quick summary of pitching, let me first say a very big thank you to our speakers who are on the line today, and also to the audience for giving us your time. Let me now introduce our first speaker, Professor Duncan McFarlane, who will talk about the low-cost aspect of pitching manufacturing.
Thank you, Alexandra. So I'll go through the big digital challenge we all have today, which is getting our systems working on the screen effectively. So hope, does that look okay? Okay, good. Right. So I've got 8 strict minutes to speak, so I'll get started. Yeah. So as Alexandra said, this set of activities we've been involved in has been around how low-cost technologies could be deployed within automation solutions, with particular focus on small and medium-sized manufacturing enterprises that have been seen to be challenged significantly by the whole notion of Industry 4 and embracing digitalisation in the large. And I should just say, what I'm going to cover here is very much focused on that asterisk down the bottom. My colleagues have actually done most of the work you're going to see here, and particularly Herman has been really great in leading our activities in pitching. So the challenge that we've been looking at within the research group broadly, but pitching's been very good to helping us focus our demonstrator work, has been around this area of digitalisation in automation and information systems, but you try to make use of the fact that there are lots of low-cost digital technologies that are not necessarily industrial that are coming on stream, being put to use. And so what we've been trying to examine is how we go about integrating low-cost technologies to add or develop new solutions that enhance the existing digital capabilities of an operation. We looked at, for example, cloud-based control in real-time systems, and using off-the-shelf technologies like machine learning and AI algorithms for process improvement. So the specific project work I'm just going to touch on over the next few minutes has been around, as I said, building some demonstrators, because one of the things we found earlier on is that when we talk to manufacturing companies, and particularly small manufacturing companies, about notions and ideas for improving the digital operations, the message sometimes just doesn't get through. And actually having a demonstration you can just show people, in the last year, it's been mainly a video, I would say, but it has been really helpful. And so, you know, whether it's automating visual inspection, using low-cost technologies for mobile computing, or doing condition monitoring, these are sort of demonstrators that have actually been really good at getting a message over and helping, create a momentum around this low-cost area, which bizarrely hadn't been receiving much academic focus until about 4 or 5 years ago. So I'm just going to go through 4 or 5 of the mini activities we've done under the Pitchin umbrella. First 2 are what I call enabling developments. So they're around preparing in automation environments to be more effectively used in this low-cost environment. So, the first development has been around putting what's called a hat, so hardware at the top of a Raspberry Pi, a very low-cost processor, but needing just integrated a commercial board that did reasonably high voltage digital communications with an industrial robot. The second example was around gearing up a production environment to be able to communicate with sensors and other information in the manufacturing environment with a PLC, an industrial PLC, in this case, a Beckhoff PLC. And in fact, these activities were both dealt with in the guise of mini hackathons we've been involved in. So we've been actually using student hackathons and other activities like this to actually look at some developments that we want to do with these low-cost tools and technologies. So that was a second piece of enabling capability. Then the next elements are 3 exemplar demonstrators we've put together, particularly so people can understand the capabilities you could achieve. This instance is the case of a 3D printer. 3D printers, despite being glamorized as being something that could revolutionize manufacturing, are really poorly outfitted in terms of integration within industrial environments. And the particular one we were looking at had very reasonably poor sensing systems on board. So we actually retrofitted with an IoT monitoring system some additional sensing that actually allowed us to do vibration monitoring, which was actually required in order to improve the quality control of the 3D printer, something that we couldn't achieve through the system that was just provided with the 3D printer on its own. And we actually used cloud-based analytics to do quality analysis and then feed that back down to the printer settings. A second example is a very simple development of a QR code-based inventory tracking system that we built in the lab, but we've subsequently been actually developing within a number of our partner companies. And one in particular is on a full-scale pilot at the moment. So this is about detecting parts that arrive into a warehouse, for example, and tracking their location where they're stored. essentially using QR code analysis and a camera connected up to a Raspberry Pi system. And the idea is that an item arrives, it gets scanned, and the system recommends where to store it. You can then subsequently search for those trays, for those parts or trays of parts, and actually get so the system actually does analysis on the existing inventory to determine best storage locations to recommend. So a very simple system. And a third equally very simple system, but again, something that's not prevalent in many small companies, is a means of converting what are called job cards into digital job cards. So a job card literally is one that describes the particular components required for a particular job to be completed, and captures the requirements and specifications for that job, then monitors how the job is evolving and records the different activities as they proceed. So again, a very simple system has been developed to support companies that would like to work on a tablet or a phone rather than on a piece of paper. So all these three examples I've just given you, the components add up to less than about £100 in each case. And increasingly what we're trying to do with them is also to come up with very quick and simple methods for developing the solutions. So just in summary, the lessons we've learned around we've demonstrated how SMEs can get access to low-cost digital capabilities, and we've done lots of outreach activities around this. And I haven't mentioned this, but one of the great benefits is that it allows students to get more involved in developing manufacturing solutions earlier on. We're developing a guide on how you best integrate software and hardware elements, and doing a lot of broadcasting at the moment. So our next steps are to doing lots of private pilots and technical support through our EPSRC Digital Manufacturing on a Shoestring project. We've got a particular activity running right now looking at IoT-based devices in hospitals. And a lot of our demonstrations systems, it's like the ones I just showed you, we're now looking at in logistics and construction sectors to see the parallels that might be deployed there. Thank you very much.
Thank you very much, Duncan. That was a very nice, very informative presentation. Could we take our next speaker, I believe Dr. Frank Tietze, talking about IP licensing and the use of IoT within.
Okay, let's try this. Do you see my screen? Is that all good?
Yeah.
Okay. Thank you very much, Alexandra, for this opportunity to present our research project here, but also everyone else who was involved in running the Pitching project for supporting it, actually. So we have been working on developing a prototype for what we call an automated licensing payment system. So this is something different to what Duncan explained. This is not so much about the actual manufacturing world, but it is about the intellectual property that sits in electronic connected IoT devices. And let's see, similar to Duncan's list there, it was also not just me who worked on this project, but a huge thanks goes here to Damiano, who worked with me in particular, and Julius, our collaborator from the Technical University of Munich. And then we've also worked closely with the computer lab across the road, I would have said, if we would have been at the IFM, and Felix here. So this is, again, a team effort. The research question we have really been looking at is over the past years, in the literature, there've been quite a bit of writing about blockchain technologies and distributed ledgers will change the way how IP is managed. And at the same time, we see increasingly complex IoT electronic devices emerging that have multitude of intellectual property in it, be this patented technologies such as Wi-Fi communication, Bluetooth, etc., but also software code that runs in these devices. So we have been exploring this question of how distributed ledger technologies can be used to actually help with making particularly the management of licensing more efficient. And while this is emerging in the academic literature, what we are seeing at the moment also is that there's quite an ecosystem emerging, that there are various activities. Most recently, there were 2 announcements from IBM and Nokia that they are working to putting parts of the patent and IP world onto the blockchain. And we've been exploring particularly how you manage and how you operate, automate IP licensing for IP that sits in these electronic IoT devices. Particularly as that process, as it turned out when we looked into it, is pretty much of a manual, old school business process. I'll tell you a little bit more about this. So when we got our pitch-in funding for 12 months, following that, we basically started also to collaborate with the Technical University of Munich in Germany. We worked with a UK SME to test out our system in their manufacturing environment and work for them to refine our prototype, which we've developed. This actually has then kind of led to starting a little company. So this is a little spin out, so to say, if you want. We've continued working with the Technical University of Munich. We were lucky to be one of the winners of the Cambridge Blockchain Prize last year. And we've participated in what is called iTeams, and we've been admitted to take part in this year's university's tech entrepreneurship program, Impulse, which we're at the moment involved in. So to go a little bit more into detail of what we are actually doing is licensing management. And this is not about negotiating licensing deals. It's actually when license deals have been signed, the operational life of licensing comes with quite some transaction costs and trust problems, etc. Here's just an example. There's not much really figures out there, so it's not so easy to put a price tag on it, but this is just a quote, an example statement here. So what we really have been trying and still doing is to tackle this problem that there's a business process which is basically not fit for the digital economy. And we have been trying to digitize that business process through a distributed ledger approach. This comes, so for instance, one particular problem is that a licensor, be that a technology transfer office or a large industrial firm that licenses out a certain technology, they receive licensing payments, but they have very limited means to actually control if the payments they receive are correct. And there are costs associating with managing those risks, running audits. For instance, we know that a company like Arm, a big licensing business, they run multiple audits with external auditing companies every year that cost them a substantial amount of money. But it's not just about the costs, but it's also about advantages that then derive from being able to automate that process. So that kind of established trust between licensing partners. And in fact, what we saw when running this project, that there's actually an opportunity for, let's say, 21st century business model, new licensing based business models that you can't really do. So how do we do that? We basically, instead of the licensee pulling our data off an ERP system and then calculating the payments and making the payments, we harvest data that comes directly from the devices. So the devices, connected electronic IoT devices, they register somehow on the network. We use that information, as we call it internally, as the hello, I'm alive signal, which means that device has been sold, manufactured and sold. This is then matched with a digital version of a licensing contract, as well as a digital version of what we call the bill of IP, which is modeled based on a bill of material. So that is an inventory register for the IP that sits in a certain electronic device. And then we can automate these payments. in the future, as I mentioned, this then enables the opportunity to move certain payments, licensing payments, out of the manufacturing process into the actual life cycle, which is advantageous for manufacturing companies and also for price competing markets. It also enables more usage-based, accurate payment models, where possibly the end customer, those who are actually using this IP, could be made to participate, which could actually result in licensors over the life cycle, generating a higher royalty income. And also, that is a bit like in the long run, it could really tackle the problem that particular smaller companies, not just smaller, but also larger ones, often have large product variety, and they could possibly only manufacture the product which has all features in it. Some are disabled and can be enabled when the customer actually wants and uses it, and then the royalty payment actually happens. So we have an architecture behind it. I think I've got to speed up here, but which is based on a permission distributed ledger architecture. And we are in, we have this bill of IP model, which we have developed, which is a database architecture. And we have developed this prototype, which is a distributed web app. And we have a simulation app on the phone, which we use to feed data into that system, which then automatically triggers this payment. So we are very much in a prototyping stage. I do have a little video here, but I think in the interest of time, I skip that and just come to the end. If you want to read more about this, there are some papers already out there that describe the ideas, a few forthcoming papers, but also please feel free to reach out to me. Thank you very much.
Thank you, Frank. Yeah, I think this project is quite special in that it has a broad remit of applications in manufacturing. So just to remind the audience, if you have any questions for our speakers, please feel free to use the chat box to pose questions, and otherwise we will have the discussion session in the end as well. So the next presentation is from myself. Hope you can see my screen. Elizabeth, can you give me a thumbs up if you can see my screen? Thank you. Okay. Brilliant. So this talk is about the supply chain theme of Pigeon manufacturing. And we will cover a selection of 3 projects which involved researchers from Cambridge as well as Oxford. We have, as the previous presenters have said, this has been a collaborative effort which involved multiple PIs, postdocs, and PhD students from multitude of institutions. So now the challenge that we were addressing. So supply chains are partly designed, partly emergent constructs, right? So they form when organizations buy from and sell goods to each other, and they create cost savings and economies of scale while doing so. The average supply chain length in the UK is 5 to 7 tiers. And in high-end industries, you have thousands of suppliers, as organizations might be outsourcing up to 80% of their production. So one saves cost, but also one ends up with risk exposure because these organizations need to coordinate and plan together to make things on time. So currently data sharing has been proposed as a prevention mechanism for risk exposure, but this is mostly done via ERP systems. However, many industrial information systems are costly to set up, which ends up being a barrier to SMEs joining in that data sharing. And SMEs form really the backbone of manufacturing in the UK. They are virtually in every supply chain. So if we have ad hoc supply chain formations, there is no incentive for SMEs to buy specialized software. And many academic papers have advocated IoT data to be shared on a supply chain, on top of which one can build analytics applications. But these sorts of musings and proposals, they tended to stay in academia. So we looked at three very different solutions that were being proposed under this theme. First of these was about the coupling of intelligent software agents, which are those autonomous bits of AI software that are the driving force behind your Alexa or Siri, as a way of sharing data on a supply chain. And the next one was about digital twinning and the role of IoT in creating supply chain digital twins. And finally, we looked at using the cloud to create a custom data integration platform between different organizations. So I'll talk about these a little bit. This first project was trying to address that ad hoc data sharing problem. So when a customer orders a set of goods from a wholesaler and the wholesaler orders from a supplier, which then deploys a third-party logistics provider who then perhaps finds a local shipper, how can data exchange hands, right? So here usually what happens is that purchase orders and shipment notices result in some estimated time of arrival, which then goes back all the way up the chain. But if we wanted to share more fine-grained sensor data along the journey, for example, for a perishable product, so that we can assure quality and traceability, how can this be actually supported? Doing this manually is very costly, and it doesn't incentivize companies to take this up. So could we find an automated way was our question. Here we worked with a local AI startup called Fetch AI to couple software agents representing each organization on the chain and gathering data from sensors. Agents then automatically send data, find each other firstly through an agent search engine, and then they send data to each other if needed securely on the distributed ledger. So the concept could also be extended to include things like smart contracting and build applications such as smart pricing or quality certification. That project led to a bigger project partially funded by the EPSRC, where we engaged with a logistics service provider. And here we are using the same technology to enable truck sharing. So this increases truck utilization and reduces costs for suppliers that are sending stuff to similar locations around the same time. So here an autonomous approach would be key because manual orchestration of truck sharing costs time and there's no incentives from the buyer organization to orchestrate this. So this results in the UK, the average truck utilization being about 60%. So we showed that the approach actually that we have proposed in Pitchin is feasible. And we are now creating algorithms for agents, i.e. organizations in the supply chain to effectively share the gains from collaboration so that they're incentivized to participate. So the second project, which was led by Oxford, looked at the concept of supply chain digital twins as the simultaneous coupling of the physical world and the virtual world. In the product or smart city domains, the digital twin is very straightforward, right? So there is a physical and we gather and update data on the physical using IoT. But what would a supply chain digital twin would mean? And how can IoT be incorporated? So here we found that through literature surveys and workshops, we found that people mean different things when they talk about supply chain digital twins. Some think that it's a fancy ERP system or it's just a simulation. And also that there are different conceptual levels. So the product level really does couple the physical product or container or truck or a fridge location in the warehouse. So normal principles of digital twinning can be applied, but the process level needs to come on top of that because it tries to infer the stage of production or supply chain that the physical is experiencing at any given time. And finally, we also have an ecosystem perspective that we need to consider. So how do we gather data from an extended supply chain? Those emergent parts of the supply chain that an organization doesn't even know that it's connected to. So can we integrate data streams almost in the form of digital surveillance from social media, company annual reports and so on to our twin of what the extended supply chain might look like? So we created a framework here, which we hope to bring alive with a follow-on project. So if you're interested, please get in touch with us. Finally, Pitching trialed a custom approach to data integration as well. So here we had the UK Warehousing Association and their members, which included the Felixstowe Port Authorities, hauliers, and the retailer John Lewis. So these partners, they needed to share data with each other on the international supply chain because they are transporting goods by sea and land, all the way from upstream vendors abroad to downstream retailers in the UK. So in these logistics-focused supply chains, timely information sharing can facilitate dynamic decision-making. For example, when can we send the haulier into the port to avoid queuing? So this project developed IoT data integration platform using the Google Cloud Service, and it was a custom approach which served as a single source of up-to-date information for all partners. And the benefits that we have been observing were reduced waiting times at the port, increased on-time delivery rates, and increased vehicle utilization. So in all these projects, we have seen that technology is there, and it is becoming mature enough for really deployment, and it can lead to great benefits for all stakeholders. Low cost and open source technologies can be used for developing digital solutions for supply chains. But the key consideration is around who will pay and who will be responsible for the platforms being developed. So I think that this will become a decisive factor in digital information sharing in supply chains. It will either be the dominant player, or if the dominant player has no role, such as what we have seen in the case of truck sharing, it will be an intermediary. But intermediaries also cost. So being a supply chain, a company doesn't see benefits unless everybody else joins. So we need to understand for different needs, what different systems may be developed to enable cost savings and data sharing. For instance, in an established supply chain, a low-cost custom cloud solution could be preferable, whereas in an ad hoc supply chain, a decentralized search engine-like approach could be created. And decentralized and autonomous approaches could be a key force in the future, but we think that trust in these needs to be developed. The architecture of the system we find is greatly affecting the performance of the system. So going into the future, more studies need to be done to analyze scalability as well as security of these systems, which sometimes present trade-offs that we need to look into. Okay, so I hope that you enjoyed a whistle-stop tour of our supply chain work. Please do get in touch with us if you're interested, because we are looking very much to expand on these lessons with more projects in the future. And thank you to all our collaborators involved. Okay, so again, please let me know if you have any questions on the chat, and we can move on to our next speakers, who is, I think, Dr. Boyang Song from the University of Sheffield, talking about quality analytics.
Thank you. Thanks, Alexandra. Let me set up my presentation. So is that possible to see my screen?
Yeah.
Hi, everyone. I'm Boyang Song. I'm a research associate for the University of Sheffield, for the research team led by Professor Ash Tiwari. I'm glad today to have the opportunity to introduce our project. It's about how to develop and apply industrial IoT and predictive maintenance for a legacy manufacturing system. A part of the work I'm presenting today is under collaboration with the University of Cambridge, Alexandra's team. Before I move to details, thanks a lot for pitching support to make all of this happen. We are targeting two challenges here. The first is about how to digitalize the manufacturing process for a legacy system, how to capture the data for a harsh showfall environment, and transmit this data to a space with better computing capacity. The second is about how to process the captured data with a machine learning or deep learning method in order to improve the manufacturing operation performance, such as the quality control or the equipment maintenance performance. Our work will collaborate with multiple partners. Our industry partner TensorBridge is a prestige manufacturer in Sheffield steel industry since 1815. TensorBridge has provided us a case study of a legacy manufacturing facility. Siemens also supporting us by providing the access to the latest industrial IoT and industrial edge platform. For the research part, we, the Sheffield team, developed the industrial IoT system and deployed the system on the shop floor with TensorBridge. We also work close with Cambridge team to develop related deep learning method. Our project in general can be summarized in 4 stages. The first stage is about understanding the manufacturing system. In our case, it is an electronic coating facility which built 20 years ago. As you can see for the photos, before our project, this manufacturing process was measured by mechanical gauges. The operator had to go to every checkpoint on the shop floor and read the gauges manually, record the measurement on the paper, then type them into Excel sheet later. In the second stage, after we figure out the priority of the checkpoint, we have tested a range of industrial IoT devices and installed them with digital sensors on the shop floor. The third stage is about the development with the industrial IoT software system. We have tested the industrial IoT system developed by Siemens called Urmetzer. It's designed to connect the machine for the shop floor to the cloud. We also developed and deployed the on-premises system, which developed with open source tools. As a result, we can monitor not only the condition of a target manufacturing process and machines, but also the performance of our industrial IoT hardware and software. In the last stage, we have developed a deep learning model trained with the captured data. The trained deep learning model can predict the critical process states, which is also the health indicator of the equipment. In our journey, we have studied with general IoT devices and sensors. Then we have realized many challenges to keep them in the harsh manufacturing environment. For example, Wi-Fi may not work around heavy electric machines because of the signal interference, so we cannot connect this device with wireless connection. Some sensors may not last long with the oil and dust. General IoT devices can be difficult to connect with other industrial devices due to a different power supply and communication standards. Then we have gradually updated the general IoT devices to the industrialized IoT devices, also updated the sensor to more advanced industrial sensors. This is a glance about the manufacturing environment in our case study. I'm just trying to give you some insight about what kind of IoT device and sensors we have deployed on the shop floor, and what the price of the hardware, what kind of data we are collecting for the shop floor. It's obviously that industrial sensor and the industrial IoT devices are much more expensive than the Raspberry Pi kind of IoT device. One achievement for our project that we have published the data we collect for this project on Kaggle. The dataset is normalized in order to avoid the exploit of sensitive business information. At the same time, it's fully functional to train a machine learning or deep learning model. The dataset has 2 parts. One is 7 years manual inspection record of key process measurement in a low sample rate, which is 3 times per day. The other part is same type of measurement collected by digital sensors and the industrial IoT system within a short period and relatively higher sample rate, which is the 1 point per second. We have provided detailed instruction of the dataset on Kaggle repository, and hope more researchers can use this dataset to understand better about the manufacturing process data and develop more and better methods to solve manufacturing problems. We develop deep learning method to predict the process condition for the following 24 hours period based on past 5 days information. We are targeting to solve the common data problems for manufacturing use cases. That you may have lots of low quality data which cannot provide you required details, and you don't have enough time to collect enough quantity of high quality data during the short period of the project. We have used deep transfer learning method to overcome this challenge. As you can see the figures in the middle of this slide, the red lines are the predictions, The green lines are the actual process condition. The left and the middle columns are trained by only manual inspection dataset or the IoT dataset. The errors are quite big. After we apply the transfer learning for both datasets, we can predict the process condition in much accurate result. In conclusion, our method may have not advanced too much in terms of deep learning algorithm development, but it has certain breakthrough to apply the deep learning method for manufacturing application. Cambridge team has also developed a demo, which is agent-based method to represent a manufacturing system involved with multiple machines. The condition of the machines varies over time. Then Bayesian autoencoder method is developed to quantify the uncertainty of condition of the machines and the quality of the product. The demo has been published on the GitHub. You can find more details there. There are lots of lessons learned for this project. The most significant challenge we have found within the project is that people from different backgrounds are speaking very different language. For example, manufacturing operators, automation control engineers, computer science researchers, they may speak totally different terminology and have a different view on the very similar thing. How to use the right language to communicate between manufacturing stakeholders and the research team is very important. The other barrier, maybe is also related to this one, is a barrier of domain knowledge. It's hard for pure computer science people to understand factory operation, manufacturing IT and OT infrastructure in a short time. It's the same to trying to let a pure manufacturing people to have a good understanding of deep learning in a short time. Very few people have the cross-domain understanding. So we probably should to work together with an interdisciplinary team or train a talent who can equip multiple domain knowledge. I think it's challenging to train this kind of talent in our current education system. For the next step, we are developing a desktop-size demonstration platform, which introducing a complete workflow of how industrial IoT system can interact with industrial control system to collect data, and using AI method to analyze the process data in terms to support decision-making of manufacturing operations. For my research, I wish to continue to investigate how to deploy machine learning or deep learning model on industrial edge device. In the future, we can either decentralize the machine learning deep learning training process to enhance the cybersecurity of industrial system, or we can remove a part of a low-frequency controller for the shop floor to a remote space. Thanks a lot for listening. Welcome to check our published data repository on Kaggle. Thank you.
Thank you very much, Boyang, for that very interesting presentation. I think many in the audience might echo your thoughts around the right language. As manufacturing digitalizes, we are seeing more and more the need for a common language between computer science and manufacturing domains. So our next speaker is Dr. Florian Urmetzer from Cambridge, and he'll be speaking about executive education.
Now, I just have to unmute myself and then we can already go. So executive education is quite an easy word, right? It's kind of an easy way of it kind of says exactly what it is. It does exactly what it says on tin. But what we came from really is the thought that if you want to digitally transfer your organization and you want to go this journey to implement IoT in your production system or in your in whichever system you want really, you want to build a platform, for example, then you can probably get a lot of people that will want to do it for you. Right? They you can hire organizations that can basically create a platform for you or create a digital system for you. There's probably lots of people that offer to help you to do it, so they take you on the hand and get it done with you. But what we really came from, where we thought we could help with or create more understanding, was how can we enable the organization to actually go this journey by itself? And there's executive teaching was one of the ways that we considered to go. So what we really started with is like, it is obviously complex to change a company to think digital, right? So there's a lot of complexity in there, aging workforce, like kind of young people, and aging, the communication between the younger employees and the older employees is complex. The organization has been built to do something which is usually not actually build new digital tools or be innovative in itself. It's there to actually stably build or build something or produce a value to a customer. So what we actually wanted to understand with this project was like kind of how can we support as a university in a wider sense, right? Is internal capability building through teaching actually something which helps, right? Which does something. We've done this in the past. We do like kind of the University of Cambridge specifically through an organization that is in-house. We do a lot of executive teaching, and it usually helps quite a lot. But what we haven't really done was this like kind of thought about this longitudinally understanding of what actually happens afterwards to these people that we teach. So what is the curricula that we need to teach? Is it technology? Is it more strategy? Is it more programming? Like kind of what is it that we actually need to put into this curriculum? And who in the organization do we need to teach in the first place, right? So they're all very valid questions, and obviously working in an organization, as you all do, you can see that they're all like kind of, they're all challenging questions as well. So our aims were basically we partnered with manufacturing companies, with healthcare companies, and with companies that were concerning themselves with smart cities in a wider sense. And we basically like kind of started to actually engage with them and say, well, actually, what is it that you need as information in the first place? And then afterwards, we basically built a curriculum to actually answer what they told us they needed. And that was basically around Internet of Things, platforms, digital platforms, and then as well wider business ecosystems. So more the thought of like, and if I have a platform, then that means I connect certain companies within this platform, but there will be, for example, companies or customers or competition or similar that are not actually connected to my platform. So how do I actually deal with these companies as well? So it's not just about the like kind of deploying the sensor and building a system, but it's as well the wider strategic thought basically. And then like kind of we basically wanted to teach as well light, and I'm saying light technical aspects, which basically means really, you know, if you have someone who's non-technical as a background or is technical as a background, but doesn't really have programming understanding or a programming background, then we want to enable them to actually experience what it is like, kind of, you know, what is it that a sensor actually does? What is it, you know, to enable them to actually do something which is IoT related, so to say. So what we've done, obviously, before the teaching and after the teaching, we've done detailed evaluations. And this is normally when we do executive teaching in the first place, we do that anyway. But what we as well did, like after a little bit of time, we basically got back in touch with the people that we taught. And we basically did another interview or another set of interviews where we tried to actually figure out what they experienced after the teaching was and how they saw themselves within the organization. So here's some of the results. I mean, obviously, like, you know, could speak for this about this for a very long time, but just some of the results for you to think about and for your thoughts. So number one is, it's not really one curricula that we can teach. So we started off with like kind of, you know, thinking there was like kind of the magic potion, and then like, you know, after we basically deploy the magic potion, but like kind of, you know, it all goes flowingly. It's not the case. So it changes over time what the organization needs, right? And I mean, if you think about it, it's logical. First of all, there's a strategic thought, right? So the strategic thought needs to be developed, and then there needs to be some form of decision process, as in how much is this going to cost? Like, kind of, you know, are we going to actually get some form of return on this, or is it just making the organization future ready? And then some form of process after that, which is an implementation stage. All these three stages as basics have different needs for understanding of the individuals involved, right? So that's number one. Then, like, kind of within the organization, if you think about this, right, like, kind of the logical thing when we approached organizations was they said, oh yeah, of course, we've got a super good IT department, right? So they're very good in repairing our laptops or whatever it is, right? And then forward went to the email, right? So And we were like, but wait a second, right? It's not actually who we wanted to address in the first place. It's not really what we thought, right? So it took a lot of convincing to actually say to non-IT people, like the manufacturing manager, for example, or like non-IT professionals, so to say, within an organization, to say to them, why didn't you come along? As well, like, so for example, the finance people in the organization need to make, in the middle bit of this graph that you're seeing there, need to make a decision on saying, yeah, okay, we can understand what you want to do. We can actually support this in a financial matter, right? So we can understand what you want to do, and we can find a financial mechanism on like how to get tax back, or like whatever it is, right? To actually like make financial decisions on this. So this is of course important, right? But it's not actually logical, and it's not really how we're thinking automatically. So, and then the next thing is use cases and value propositions, and as well strategic aspects are actually in their nature often unclear, right? So even when you're coming to this decision and prioritize process, which is the second step, there is still uncertainty, right? It's never really, you know, if I take this hammer, bash 3 times on this piece of metal, I'm going to have a dent which is like kind of X millimeter deep or something like that. It's not like this, right? It's more complex. It's more liquid in a way. It's more, as you're learning, as you're going along, you may actually need to change things and build things in different ways. So, what have we learned out of this in the first place, right? So like, let's take a step back, so to say, right? So number one is actually, we found that when we're taking specifically non-IT people, but then as well IT people who have no IoT background, we actually have impact on them when we teach them, right? What does this mean, right? Like, so people used to say in the longitudinal interviews, well, I went back into my organization and I started to see all these things which I could actually use digital processes or a digital platform to actually optimize, right? So the second thing that happened, and I'm going to come back to this first one in a second. The second thing that happened was people were like, this was super useful, and I could talk about this with 3 of my colleagues, right? And they all want to come as well now. Right, so this is obviously like great, because I mean, you know, it's helpful for us. There's more going on in a way. But what we found as well is like not actually every organization in itself needs exactly the same content. There's a slight discrepancy, even at the core of the understanding is actually the same that the organization needs. Right, so even though that everybody kind of needs the same, still, right, like if we're thinking about platforms or IoT, like using sensors to execute business in a way, right, what some of my colleagues have been talking about before, there's a difference in like what you actually focus on from a teaching point of view, right, from a deeper understanding point of view. But as well, like when I said, I'm going to come back to this first point. When people see these opportunities, they actually start to go into their organization then as well and say, well, actually, there's interesting, look, I've found this thing, right? Like and like, look, if we use a sensor there and then do this, right? Then we could actually build this and make this way more efficient. And for example, they then go to the IT department, and the IT department's reply is, what, your laptop is broken? Tell me, how can I repair it? Right? The IT department is not automatically built to actually build a new system or to help with a problem like this. So therefore, people actually like felt very much that they were then enabled, but the organization was not enabled. And that's obviously like, and that shows as well that if you're influencing the organization at different points and you're thinking about this strategically, you can actually have an impact on the organization overall, and like have an impact as well on the transfer or towards a digital or towards digital thinking within the organization. So So we have developed this curricula, obviously. So what we're doing next is like, and we're running more courses, which is one thing. But then we are interested as well, kind of this hourglass model that I showed earlier. We're interested as well to like kind of go through this hourglass model, and for that we of course need the companies that are interested to support this as well. You know, we can't do everything for free, sadly. Pitch in will be ending soon, but we are looking to build this consortium of organizations that are interested to actually go this journey with us, and where we co-learn to actually build this as a from an inside point of view, but as well help these organizations for themselves internally to actually do this. To do this transfer into digital, rather than actually like in walking and doing it for them and then extracting ourselves as well with our capability. I think that brings me to the end of my talk. Thank you very much. And if there's any questions, happy to answer them later on. Back to Alexandra.
Thank you very much, Florian. I believe our next speaker is Professor John Clark, who is the lead principal investigator in the Pitch-In project, and he will give a general overview.
Okay, can you see my screen?
Yeah.
Okay, so I'm John Clark, I'm the PI for Pitch-In. Thanks to all the speakers, incidentally. I'm having a good time. I hope everyone else is too. Wider challenges and future prospects. So that's what I'm going to be talking about in a moment. Oops. Yeah. Okay, so one of the big challenges and also opportunities, it's pretty much the same thing if you, depending on how you look at it, is security generally. So we've had some people already talk about security being important, and it is, and it's going to get increasingly important. So if you look at just some aspects of device and system security, actually Industry 4.0 inherits all the old problems and quite a lot of the new ones. So you inherit all the problems of any computational architecture which you choose to embrace. So for example, cloud, if you use cloud, you inherit security problems from cloud and lots of other sort of things. Interesting issues do arrive if you now try to do things very low cost. So I think one of the really interesting issues in security is the interaction of low cost and how much security you can provide. And this is not uncommon in other areas. It'll be an issue in our areas too. Securing legacy systems is going to be a major issue. Very few people start with, you know, first catch your rabbit or whatever, Mrs. Beaton's cookbook type things. They start with the system in place quite often. And frequently we're going to be in manufacturing, are going to be faced with how do we secure a legacy system, and actually how then do you gradually transition from that system going forward. But securing legacy systems is going to be important. Secure updates is an opportunity and a challenge. It's arguably quite a lot of devices, frankly, out there are not secure at all, and some have absolutely no security built in or security capability. But what we're going to have to do going forward is look at secure updates. Because security, you need to patch in the same way that we patch our laptops, to follow on from the previous speaker, you need to patch your systems as well. You need to be able to update and update securely, because the actual update mechanisms themselves may also be a problem. We're in the manufacturing is in the crosshair, in the spotlight, if you like, for advanced persistent threats. Stuxnet, for those of you who remember it from 2009, 10, 11 or whatever, attacking nuclear reprocessing facilities in Iran, was a phenomenally sophisticated bit of technology targeting Iranian reprocessing, materials processing facilities there. We are in manufacturing is in the spotlight, in the crosshairs. I've got it down here. Some questions do arise. Because a manufacturing system is not a general purpose internet-oriented system, it has its own very specific characteristics. There may be opportunities actually which are advantageous, which enable us to, for example, craft, engineer intrusion detection systems. Just finally, that's all the cyber stuff, but you also get the physical as well. Even questions like how you make IoT devices resilient to what I've described here as RF drive-by shootings. It's actually not too difficult to put together some kit with a variety of coils and batteries to actually cause major havoc in circuitry at low cost. It was demonstrated back in the late 90s in Sweden, where people managed to put RF stun guns together, if you like, and stop Volvos and Saabs at 50 meters. That takes some doing. That was all the general stuff. Here are some particular things. The various speakers have referred to digital twins. Well, we have an interest also in digital twin security. It's hardly addressed as a research issue. So we're interested in the security of digital twins in manufacturing. digital twins are big in modern manufacturing, and they can be a point of weakness, and they have their own specific threats that need to be dealt with. We aim to build a community, Pitching aims to build a community, supported here by the EPSSC and NCSC. So if anybody is interested in this area, get in touch. My email is at the end of this, this presentation. Regulatory issues seem to be a major. So many manufacturing processes are simply inherently dangerous. So steel processing, one, you don't want to get in the way of hot steel, for example. But there are actually also a variety of other manufacturing processes which are just dangerous. And these are some technologies associated with Industry 4.0, for example, collaborative robots, where humans work with robots to best overall effect, raise significant safety and related issues, reliability issues, and things like this. There's a need to consider safety and security issues together for these sorts of critical systems, dangerous manufacturing systems. And as an analog to what I actually said on intrusion detection, we have to consider forensics. We have accidents in the workplace, and that's going to happen with Industry 4.0 systems as well. And now the question is, do you have the information to reverse engineer a narrative from the information you now have available? Health and safety executive have great interests in that sort of area. But actually, when you consider the possibility that a cybersecurity incident attack may actually occasion a physical safety problem, then it gets much, much harder to reconstruct the whole scenario from available data. And I would point out, when you have complex supply chains or complex multi-party systems, getting the forensic data, just getting access to the forensic data is really rather hard, and that's going to be a major challenge. So remote operation and management, this is close to a variety of people's hearts presenting today. So we heard Boyang, but it's a big interest at Cambridge, and it's a big interest at the AMRC and at Sheffield as well. So remote operation and management is a big issue across the manufacturing field. Now, we've seen a major increase in interest in remote operation and management since the pandemic for obvious reasons. In fact, it has really primed or speeded up progress toward very, very rapidly over the past year. People are trying to concertina their ambitions in this sort of area. It may raise interesting challenges for computer science or things, for example, delivering reliable control and management, bounded latency, depending on the sorts of systems that you're actually engaging with, also security, etc. But it's a major opportunity for research and innovation. More opportunities or challenges, depending on whether you're a pessimist or an optimist. Complex systems generally, this is known in other disciplines, but complex systems in Industry 4.0 and in manufacturing as well. There are major integration issues, and particularly with large complex systems. And of course, if you have a large complex supply chain, they're a particular problem. Getting any sort of security standardization and competent risk management across a big supply chain is known to be a difficult issue. And it goes from, say, how do you secure an oil pipeline? That's difficult, right down to even just a collaboration where people have different competing interests. The data sharing needed to do security and make good security analysis and take actions it assumes really that you have to be able to take collegiate action, and you need access to the right data. It is just difficult. The other thing I would observe that in many systems we are seeing a convergence of IT and operating technology or operational technology. Operating technology is the control systems, things that make stuff happen. IT is the stuff that goes on around the outside, doing the various bits of processing, monitoring, billing, and all the rest of it. These are converging, and we are seeing increasing amounts of these just actually essentially becoming part of the same system. This raises distinct reliability and security issues. And we've seen examples of OT, the stuff that matters and hurts when it hits people, actually where the attack vector has been launched initially on the IT supporting infrastructure and admin systems. There are the leveling up or build back better agendas. If you know precisely what those two mean, please tell me. But there are these general purpose agendas which are out there, and others, incidentally, the Prime Minister's 10-point plan and all the rest of it. There are significant opportunities for manufacturing in things like the modular manufacturing of houses. And if you consider what people want from houses, they want it low cost. Well, we've heard about that big time already. Major opportunity. They want it resilient, they want it secure, they want it integrated, etc. So I think issues of that which are associated with build back better or leveling up, just essentially, you can see much more of this, and there are opportunities for manufacturing, and all the usual issues come to hand. And finally, it's not all about the detailed control tech, and as I said, that's where my head is really, but it's not all about that. So things like visualizing or insight rendering in Industry 4.0, I think insight isn't always high profile. Even in machine learning, when people talk about machine learning providing insight, what they often provide is machine learning. But the dashboards, etc., the rendering insight is going to be increasingly important. And I think, well, we know that that's going to be important. It's important for manufacturing as well. And finally, just to follow on from the last presentation by Florian, skills development. There's further opportunities for that. There's other stuff going on on pitch in, but it's a major opportunity for us to impact on how people behave and facilitate regional engagement and the regional economy by providing such skills. Skills, of course, is a plank of Make Smarter. So that's it from me. That's who I am on the left, and Sarah is the pitch in operations manager. And there's a bit of, if you want to get in touch, please do. So thank you.
Thanks very much for this, John. I think lots of interesting, thought-provoking observations there that we need to think about as a collective. So I think we are now moving on to the Q&A session. Let me just share my screen. Hopefully you can see my slides, which means I can't see the chat box anymore. Just a moment. Right, sorry. I think I'm gonna have to do this without opening the slide set. Okay, so I think we have a few questions that were raised by the audience for our speakers, so we can go through those sequentially. So David White has asked a question to Boyang. Could you give, so you gave many examples of hardware you used. What software cloud services did you use to store and analyze the data, for example, MindSphere or AWS? I'd be interested to hear how you chose software infrastructure.
Okay, thanks for the question. So I think you're thinking how about to develop architecture of an IoT solution for manufacturing use case. I think first you need to, we are considering where we are doing for research or for production. I think at this moment, majority of these tools still is in R&D stage. I don't think this is a mature technology at this moment. So, and for manufacturer, if you want to connect your production line to the internet, just to make sure you're prepared for that. Can you defend your production line for the outside world? So I think you gave a lot of the example for the cloud technology, but are you ready for connect your production line to the cloud? Are you going to try something maybe on premises? I mean, on your local server. The other things to design the architecture or to launch this project, I think this kind of system, majority of the system still is bespoke system, which need a lot of time to understand the demand, understand the existing thing for your manufacturing system, and to design some customized system. So it needs a long time to design a system and launch the system. So in traditional manufacturing information system world, they maybe they have a consulting spend 1 year to understand the customer's need, and they have a design team to design the system, then have the implementation team, and also have the change management team to change the culture of the organization. So I think that this is a long process, and a lot of effort need to make, and a lot of people need to get involved to make a successful IoT project. Thanks.
Thank you, Boyang. I think we have a couple more questions for you, actually. Yeah. So you mentioned about the development of a common language. So how would you explain deep learning to the operations management at a factory?
Okay. Yeah, I think this is one very challenging thing we have tried many times, and since when I start explain how the algorithm work, the people on the show floor may turn off. So just trying to not overwhelm the manufacturing people, because think about either it's deep learning or other tool, it's just a tool. It's a technical tool to serve business code. what is the business goal is, I think, is operation management. Operation management is how the manufacturing and supply chain work. So I think when we talk about this technology, you're right to explain the detail of this technology, trying to find a language for operation management. And for the people just getting into manufacturing system, just beginning to understand manufacturing information system, maybe it's worth to look at some just already existing standard, like the ISA 195, which is developed for manufacturing info system architecture. So they have this kind of a standard already exists. So try to borrow some language or word for them. They are more familiar to the manufacturing people, and use this kind of language to communicate with manufacturing people on the shop floor, to communicate with manufacturing business owner. I think that will help you better to explain the technology, which help them to get benefit more to help them to achieve the business goal.
Yeah, thank you. Just looking at some other questions, I think we had one for Duncan and Herman on low-cost solutions. So if any of you are on the line, can low-cost solutions be deployed for other teams, such as supply chains for monitoring and data sharing?
I think Herman's connection is not really working, but I can answer a little bit about that because I do work on shoestring with the guys. There are demonstrators that would help with supply chain. For example, there's part identification and tracking demonstrator, which would help with knowing what parts are in what part of the located in what part of the warehouse and what's depleted in supplies. You've also then got low-cost monitoring technologies for goods in transit, like temperature monitoring. And again, we've been looking at that, and I think you have, Alexandra, in some of your projects, haven't you? And then we're also looking, with regarding to data, we're looking at low-cost technologies that demonstrate data collection and management of data as well. So there are numerous ones. So if anyone wants to get in touch with the shoestring team or with me, and I can put them in touch, they can find out more. And the logistics, there's an affiliated project to shoestring, digital logistics on a shoestring. So they're looking at all these different types of technologies. And we're also looking at how to deploy that in hospitals as well, especially with the temperature monitoring.
Yeah, I guess, John, you have raised a very good point around low-cost technologies and sort of technology that's been developed for generic purposes, and how that might sort of present security challenges. So I wonder what your thoughts on that is.
Yes, I think someone else also, I think it was Stephen, asked a related question, which was, is it just the price you pay? And to some extent, the answer is yes. But there are things you can do. You can basically limit the authority and limit the effects that things cheaper that matter in interesting places, you can just limit what they do. So, and you can also actually architect your system so that they don't actually need to be that secure. I think the important thing is to understand what their capabilities are, what the threats to them are, and then you can architect your system hopefully appropriately to make sure that those things don't occur. So you can do things outside the device itself. So for example, if there's no chance of, to follow up on my radio frequency example, if there's no chance whatsoever of any sort of radio frequency RF attack, because it's housed inside a fairly thick-walled building or whatever, then the issue doesn't arise. So you need to place it in context, I think. But yes, but there is an interesting research challenge, which is, can you make even very cheap stuff secure, even if it isn't at the moment? I think that's, which is part of the rationale for it's an opportunity for research as well as just coping with the practicalities.
That's a very good point in terms of the context as well. And continuing on the security thread, I guess, a question, related question, I guess, for Frank and Damiano, is the time lag for encrypting and decrypting a problem? How fast are the transactions on the IP licensing platform that you're supporting with blockchain?
Elizabeth, you need to
Hi.
Yes, thank you.
Hi.
Yeah, so basically in our use case, so in our kind of application, there are two very different time scales between the, let's say, blockchain layer and our actual implementation, which regards royalties. So basically royalties are computed often with a very high granularity. We're talking at least about months or even weeks, but this is a completely higher level compared to the milliseconds that takes for then the actual transaction to go through. So in our our real implementation right now, we're considering two different blockchains system under the hood, let's say. So we have both Hyperledger Fabric and Quorum, so basically a permissioned Ethereum clone. And in both cases, the validation time, the average validation time, let's say, is below 1 second. So basically transaction, even during very congested times, take less than 1 second to be validated, which means that, of course, this completely supports royalties that need to be computed in a scale of, let's say, at least weeks. And of course, we can even support another business model for like hourly rate computing of royalties and so on. So that is, I agree that that is an issue depending on the application, but for our use case, that is not.
Brilliant, thank you. For Florian, we have got a question on how do you teach a technology that's constantly evolving?
Okay, fantastic. I was just answering it in the chat, so that's why I'm laughing. Sarah, thank you for that. That is a tricky one, right? From a university lecturer point of view, I think the answer is teach concepts and don't teach the technologies themselves. But at the same time, when you teach the technologies as well, you can teach them in a way that they are an example for transferable knowledge, as in that you actually enable people to, you know, when you teach people how to program Java, you can teach them how to program as well, and use Java as the application mechanism or the mechanism to teach the structure of programming language as well. And I think there's an importance there on referencing or thinking about that when you develop your curriculum. I hope that answers the question.
Thank you. And another question for you, Florian, from David, is how do we bridge the gap between fixing laptops and the cloud architectures needed for IoT systems built using AWS, Azure, etc.?
Yeah, perfect. I've actually answered that in the chat already, but it doesn't matter. Like, I can still answer it. So my initial response is separate those people who are super interested in fixing laptops and those who are actually interested in innovating. IT departments specifically tend to be super resourceful. So if you, I mean, obviously incentivization and enabling people to evolve in that situation or get something as well back from that situation, and not just saying, well, actually you used to fix laptops for a day, now actually why don't you do that in the morning, in the afternoon we do this innovation thing, you know, and expecting the same output on the laptop fixing as well as on the other stuff, and that's obviously a problem. But generally is yeah, it is possible to get resources out of everybody, really, like kind of who's interested in innovating. And not everybody is interested. There's different stages in life where you may not be interested in innovating and driving innovation. There's stages in your life where you may be super interested in actually taking on some extra work because it's challenging and you're keen to do something extra. So I think there's a question about that.
Thank you, Florian. John, we have loads of questions popping up for you. I'm just going to go through them. What's the way forward for security systems, methods, standardization, and interoperability? That's a big question, isn't it?
That's covering an awful lot. I mean, I think we will see standardization of various IoT protocols, for example. That's happening in other areas. From a security point of view, it'd be interesting to separate those things which are actually domain specific from those things which are general. There's already actually quite a lot out there on IoT security, and there are standardization efforts underway. I think from a manufacturing point of view, it would be interesting just to give some thought as to what is curiously or with emphasis applies in the manufacturing domain. My general feeling is you face both physical and cyber attacks, the complexity of the systems, the supply chains are going to be a big issue, full stop. And I do think that there's opportunity to, just following up from one of your earlier questions, which is related, to develop guidelines to induct people into thinking about security in their systems, and I think that would be a major step forward. You know, if IoT is going to take off, you know, across the UK or across the world, etc., people need to think about the security of their systems up front, and actually just engineering that shift. And that's the sort of thing that the NCSC do. They released Smart Cities guidance last week. They released other things. They're already doing work in supporting research in IoT in the home, which incidentally is going to be another big nasty area. That's an accident waiting to happen. I would imagine. Oh, the other thing to just point out is that the British BSI have been working on manufacturing security risk analysis, and I actually think it's quite good, incidentally. So there is some aspects of standardization out there. I have no ability whatsoever to predict what's going to happen to comms worldwide in this. It's a bit of a free-for-all, but there is risk management advice out there, and I think what you'll see, and some of us are working on already, is the emergence of guidance for particular aspects which are of particular relevance to manufacturing. I still think there's a big issue with IT and OT, which we are seeing convergence, and it's just going to be problematic. But there is a lot of security experts here, so I'll be positive.
No, absolutely. I think, you know, when you look at the convergence between computer science and manufacturing, so it affects a singular organization already. And what happens when we open it up to supply chains, data sharing? So very interesting streams of research that need to be done. Second question, are security issues part of the price you pay for low-cost technologies?
Yes. Right. So I mean, it may not be inevitably so, but in practice, it's partly part and parcel of doing that. It's not to say you can't engineer cheap systems. It's just that there are issues involved with those. Indeed, as there are issues involved with engineering low resource computational pieces of equipment and requiring security, because it's well known, you know, for example, the security you can get from a very low power, low memory, just generally low resource chips, you limit the security you can actually do. So you need as much security as you need, but no more really. And what's the best you can do in those sorts of situations? But by and large, there are trade-offs. You know, you turn down the resources, and that includes money. It also includes, you know, zip, if you like, how many instructions you can, crypto instructions you can do, so, or how many gates you've got on your chip. If you want to implement elliptic curves, quite a lot of smart cards, for example, part of embedded systems all over the place. You can't fit elliptic curve cryptography on the chip. So there are always resource delivery performance issues. And just because the question is, how do you optimize that? And are there smart things you can do to make the best use of those resources? And the crypto people are onto that in particular.
Right. And in terms of, I mean, I guess that leads to that next question from David. On a scale of 1 to 10, based on your experience with SMEs, how prepared are SMEs for cyber attacks in manufacturing?
Largely not at all. In fact, one of the interesting questions is how people have got away with it for so long, and that may have just been that they limited connectivity, for example. I've seen actually major commercial operations, their current IoT, if you like, is just on an internal network, not connected to the outside world. So none of the cloud stuff, none of anything have gone to that, and that's how they're managing their risk. When they are those that are concerned, and many are concerned in a general way, those that are concerned specifically can be quite paranoid. Okay. So I don't think there's any little in the way of middle ground. So SMEs generally, and it's not just in manufacturing, it's across the board, are poorly prepared for an awful lot of stuff. The last thing we should encourage them to do instead is to go off and invent their own. They really do need to, we do need security out of the box, or easily accessible security, etc. You will see more guidelines coming downstream, incidentally, for manufacturing. That will just happen. And the way the NCSC has gone about things is that they give entry level, but then and you need consultants. You need expertise. You can't get away with it. You know, if you want real insight into how to do something, you need expertise. At the end of the day, there are guidelines which will be produced, and there are some centers out there already, which is essentially how to get started in that sort of space.
Thank you. Thank you, John. And there was one last question, which I guess is a general question I'm happy to answer. It's about which countries are setting the pace on industrial IoT in manufacturing. So I guess, you know, if this was a couple of years ago, I would say Europe, mainly led by Germany. Which is sort of at the front for within shop floor, within factory kind of digital manufacturing, I would say. So lots of initiatives going on, especially in the automotive space there. And the US looking mainly at the design stage, whereas I think the UK now is very much catching up, if not leading the AI and data analytics stage, I think, within IoT, as well as cybersecurity. So, so I think that, so we have got just the 1 minute left. I just wanted to put up one slide just as a closing remark, and to say thank you to all our speakers and the audience. Hope you can see this slide. So, so thank you so much for joining us. And we would love to hear from you. So, so we have got our events listed on the Pitch-In website. So just Google Pitch-In manufacturing or Sheffield, then you will definitely find us, and feel free to contact us on the different projects as well as the manufacturing theme. We have got the Cambridge Executive course coming up on the 15th of June, and we also have the IoT conference, which will be on the 16th of June. So, so please follow us in Twitter as well. And we look forward to hearing from you and looking at the next stage, really, of IoT in manufacturing in the UK. So thank you again for joining.